notes on this one are going to be a little bit different format. We're going to do a warm-up exercise before we get started. So I know you're going to be tempted to just skip through it, but it really will help you kind of make sense of the lesson as we go through it if you take the time to get your mind thinking about this from the right perspective. So when I tell you in the video to pause and try the warm-up, please do so. I think it'll make a big difference. So let's go ahead and get started. Lesson 3A3 is going to give us another tool to put in your quadratics toolbox, and that is factoring when you have a trinomial and a is equal to 1. So our learning target for this lesson is I can factor quadratic trinomials of the form x squared plus bx plus 6. We don't have any vocabulary this time, so we're going to get straight into the notes. It says we now need a strategy for factoring polynomials that have 3 terms. We call these trinomials. After looking for and factoring out a GCF, you always want that to be your first step. We are then going to see if we can factor more using this method. Now, I want to clarify a little bit the title here. When it says a equals 1, but then we look at the learning factor and there is no a, that's because the standard form of a polynomial is, come on, give me a pen, is ax squared plus bx plus c. Well, in this lesson, we're talking about a being equal to 1. So if this was equal to 1, 1x squared is just x squared. So that's why it has the form in this way. We're going to do things a little bit differently this time and have you do a warm-up. So what I want you to do now is pause the video and take a minute to read through these and try and answer them. It says, think of two numbers whose sum is 8. Remember that sum means you're adding. So two numbers that add up to equal 8 and whose product, which means multiply, is 12. So the same two numbers that will be multiplied to give you 12 or add up to 8. So go ahead and pause the video now and try and complete this warm-up. Okay, I'm going to walk you through how I thought about the first one and then just kind of give you the answers to the others. And if you want some clarification, you can ask us. So for the sum of 12, I find it easier to think about the product first. So when I think about 12, I know my factors of 12. I could say 3 times 4, or I could say 1 times 12, or I could say 2 times 6. But 3 plus 4 is not 8, it's 7. 1 plus 12 is 13. 2 plus 6 does add up to 8. So that means that I'm going to say 2 and 6 are my numbers there. For this one, two numbers whose product is negative 14 and they add up to 5, that would be 7 and negative 2 because you need one of them to be negative to make this be the product to be negative. And since the sum is positive, we want the larger number to be the positive one. Two numbers whose sum is 16 and product is 15 would be 1 and 15 because we add those up and get 16. Here, my product is positive, but my sum is negative. That means I want both numbers to be negative so that a negative times a negative is positive 40, but negative 4 plus negative 10 is negative 14. All right, if you haven't already done the multiplication part and answered these questions of the warm-up, go ahead and pause and do that now. I'll wait. All right, when you multiply this, please remember that when we multiply binomials, it is a distributive property situation. So you're going to say x times x, x times 3, 6 times x, and 6 times 3 for a final product of x squared plus 9x plus 18. And over here, when you do that, you get a final product of x squared plus 5x minus 14. If you need a refresher on that, go back and look at Unit 1, Lesson 11. All right, what do you notice about the sum of the constants in each factor? That means, what do you notice about 6 plus 3? Where does it show up in your product? And then the second question is, what do you notice about the product of the constants in each factor? So the product means multiplying 7 times negative 2. Where does that show up? So what I notice is The sum of these two numbers in both cases ended up being the coefficient of my x terms. 6 plus 3 is 9, and that's where that showed up. 7 and negative 2 is 5, so it showed up on that x term. Whereas the product becomes the constant in the trinomial. 6 times 3 is 18, and that became my constant. 7 times negative 2 is negative 14, and that became my constant. So let's try and take this information and use it to factor a trinomial. Factoring a trinomial is exactly like multiplying binomials in reverse. Instead of taking two binomials and multiplying them to end up with three terms, we're going to take three terms and break it apart and figure out what those binomials were to multiply it. So to help you do this, I really think that drawing yourself a little table to help organize your basically guessing and checking. And keeping your thoughts organized is going to be really, really helpful here. So let's get started. The first thing you're going to do is write down basically a shell of your two binomials. Whenever A is 1, whenever your number right here is an understood 1, you're going to start with two things being multiplied, and you know that the first term is both of them is x. Then what we want to find is numbers that multiply to give us 8. So I want factors of 8, because remember that your product of the two numbers gave us this. And I want sums that add up to 6. So start with your factors. Factors of 8 are 1 and 8. Well, 1 plus 8 is 9, so that's not helpful. 2 and 4. 2 plus 4 is 6. That's the one I'm going to use. So what I'm going to then do is go right here and say, okay, that's a positive 2 and a positive 4. And that's it. So just to check us, we're going to go ahead and distribute this to show you that these are the binomials that were used to get this trinomial. So x times x is x squared. X times 4 is 4x. 2 times x is 2x. And 2 times 4 is 8. Then I combine like terms. So 4x plus 2x is 6x plus 8, which is the trinomial we started with. So your answer is x plus 2 and x plus 4. Example 2 is a bit different because this time we've got a negative here for our product. So the process is still going to be the same. Let's go ahead and switch to the skinny pen. We're going to start by saying our shell here. Because A is 1, we get to say just x and x. The factors that we're looking for this time is we want to have a factor of negative 45, and we want the sum to add up to 12. So 12 is what we're looking for. Now, the factors of negative 45, you can start like we did over here with 1, so that'd be 1 and 45, or negative 1 and 45. But we kind of know that's not going to work because we're trying to get it to add up to 12. Negative 1 plus 45 is going to be much too big of a number. Notice I am putting the negative with the smaller number. That's because in this case, my sum is positive. So I want to have more positives than negatives when I go to add. The next thing that comes to my mind here is negative 5 and 9. Negative 5 plus 9 equals 4. So it's still positive because I put the negative with the smaller value, but now it's too small. So I need something that's a bit farther apart. Oh, I know. How about negative 3 and 15? Negative 3 times 15 is negative 45. Negative 3 plus 15 is 12. And there it is. So that means that my answer, because this is negative 3, I'm going to put minus 3. And because this is positive 15, I'm going to put plus 15. All right, let's come down here and try one where my sum is negative. So this time I'm looking for a positive 16 for my product. My sum, though, is negative 10. This time when I write the shell, I'm going to put y instead of x because there are y's here. It's not really going to make a huge difference as far as the process goes. So since my sum is negative, but my product is positive, that means I need two negative numbers because negative 1 times negative 16 would be positive 16, but negative 1 plus negative 16 is going to be a negative value. So that didn't get me the answer I wanted, but it is at least the right sign on my answer. So the next thing I'm going to try is negative 2 and negative 8. Negative 2 times negative 8 is positive 16, but negative 2 plus negative 8 is negative 10, which is what I was looking for. So when we plug this in here, negative 2 means I'm putting minus 2. Negative 8 means I'm putting minus 8. I'm going to just one more time actually go through the process of multiplying those to show you again that this does work out to be the trinomial we started with. So y times y is y squared. Y times negative 8 is negative 8y. Negative 2 times y is negative 2y. And negative 2 times negative 8 is positive 16. I'm then going to combine my like terms. Negative 8 and negative 2 is negative 10. That y squared is doesn't have any like terms, and the 16 doesn't have any like terms, and that is exactly what we started with. So that's why my answer is y minus 2 times y minus 8. All right, last example I'm going to do with you is right here. In this case, both of my elements are negative. So I'm still looking for factors of negative 28. But my sum this time is also going to be negative. So think about what that means for our factors. That means one of them is going to be positive and one of them is going to be negative, because that's the only way to get a product that's negative. But since my sum is negative, my larger number needs to be the negative one. That's what's going to result in a negative sum. So for example, if I start with my 1 here, 1 times negative 28 would get us negative 28, but 1 plus negative 28 is going to be negative 27. So that's not the pair I'm looking for, but again, at least it got me the right product, and my sum is the right sign, so I know I'm kind of on the right track as far as where to put my negative. If I go to 2 and negative 14, that is 2 times negative 14 is negative 28. 2 plus negative 14 is negative 12. So again, it's negative and it's getting closer, but still not quite there. 28 is not divisible by 3. 4 times negative 7 would give me negative 28. And 4 plus negative 7 is negative 3. There's the one I want. So when I write my shell this time, I'm back to using x's. And I've got a positive 4, which means I'm putting plus 4, and I've got a negative 7, which means I'm putting minus 7. So that's my final answer. So our answers when we're finished factoring, I just want to make sure I hit this well enough that you understand. Your answer to example 4 are these two binomials, x plus 4 times x minus 7. Your answer here was y minus 2 times y minus 8. Your answer here was x minus 3 times x plus 15, and your answer here was x plus 2 times x plus 4. Later, when we're actually trying to solve some quadratic equations, we're going to be using these factors in order to get a solution. But for now, the answer to this is just what are the two terms that you multiply to get this, or the two binomials that you multiply to get this trinomial. It is important to note that not every single trinomial is factorable. So if you've tried every combination of factors and none of them are working, then write non-factorable and move on to the next question. It doesn't mean you've messed up. It's perfectly feasible that that is just a trinomial that doesn't have nice, pretty numbers that can be multiplied to get your product. So don't be worried by that. It's kind of like getting a no solution. Once again, with this lesson, there is not an application. You're so welcome. Trust me, they are coming in this unit, just not till later on. So enjoy it while it lasts. Let us know if you have any questions. Bye, guys.